there we go.
All right. All right. Ah. We're golden. Welcome, everybody. I get to see the monkeys behind the screen.
The peanut gallery.
That's right. I'm Tim, who's recently shaved his beard off. If you've looked at some of our other videos where you actually see my face, I usually sport a beard, but it's too warm this summer for that. Lorenzo, the man behind the technology and linear algebra dude.
I'm the cause of all the tech problems.
That's
yes.
right. So we're doing a test run this morning on streaming from campus with a chalkboard. Glorious chalk.
We will not be doing the applications of Diophantine equations and further.
We'll edit that later.
Yeah.
But the thing to keep in mind is this is impromptu and it's live, so who knows what's going to happen.
That's right.
Because there will be chaos, and none of us brought a calculator today, so we're going to be doing hardcore arithmetic. Because it's all about the chalk, don't you know? Okay.
Which we will toss at you if need be.
That's
Settle down back there.
All right.
All right, let's introduce the test statistic.
Okay, so
or I guess maybe
what we're going to do
background.
is we're going to walk through the three tests for chi-square. The first one's going to be goodness of fit. So we'll let Lorenzo talk about the function up here, the summation expression on the board behind me. But the idea with goodness of fit, and this is applicable to many, many students who want to apply statistics or are asked to apply statistics in a biology course, who oftentimes want to, you have measured values in different categories. Genetics comes to mind. I always use the Hardy-Weinberg equation as an example. We're not going to do that specific one today.
Next
the
time,
idea,
though, because now I want to do that.
Okay, well, we still can,
Oh.
It's p squared plus 2pq plus q squared, which is p is 0.6 and q is 0.4. And if you work it out, it all equals 1.
That's right. I like your soccer player one, though.
But we're going to do the soccer player
That's right.
one.
All right.
So what we're going to do with goodness of fit is we're going to try to, I'm going to eventually look up the original study. The numbers are perverted because I don't remember and all the exact details, and we've chosen them to be easy to work with today. But I will cite the study when I go look it up again one time. So the idea is in sports, star athletes, are they born or can you teach someone to be great? Now, the study we're referencing is World Cup class soccer players, but here in Canada, that could be hockey. The rest of the world would be soccer. We don't care what the Americans do because right now they're kind of silly.
Doing their own thing.
They're doing their own thing. I'm sure there's I'm not even going to make a bad joke there. Because remember, this is live, and I'm not editing anything, and, shut up, Tim. Okay. So we're going to put up a representative example of this study. So it comes down to this. What the study authors did was they looked at the birth dates of every player who ever made an appearance in a World Cup class soccer match, recorded their birth dates, and then categorized them into one of the 4 seasons. And one of the flaws with this, obviously, is what's spring in the northern hemisphere is fall in the southern hemisphere. So as I recall, they had a way to deal with that, but we're not going to worry about the finer points.
Just by ignoring the southern hemisphere and just saying you are now fall.
Yeah, that's right.
Yeah.
But at the end of the day, it comes down to, is the distribution of birth dates such that there's no pattern? In other words, how do they compare to how does the observed values compare to the expected values? And what is the expected value? Well, if you have 4 seasons, let's say, and we're going to work with the number 1,000. So if we have 1,000 players and there's no relationship between the season they're born, then you'd expect 250 to be born in each season. However, if there is an effect, the time of year a player is born, then we should see a discrepancy. And that's what the goodness of fit test is going to do. So with that in mind, I think that pretty much lays it out. I'll turn this over to Lorenzo, and he's going to walk you through the computations, and we'll start off by explaining what this bad boy is behind me.
Yeah, so we want to know if it's random these birthdays of the soccer players. So to do that, we'll need an observed value and an expected value. The expected value is the numbers we expect to get if their birthdays are truly random, so 25% chance of being born in one of the 4 seasons. This will give us our test statistic of chi squared, chi squared, or chi squared. It depends on the language.
Even worse.
Yeah. So this whole thing is the test statistic. When I was first learning this way back when at McEwen, I was like, so do we square it at the end, or what's up with this? No, the whole thing is chi squared. This is what you're
hurting my head.
Yeah, I know. It's what I do here with math and stats. So the whole thing is chi squared, which means we take the sum, that's capital sigma here. This is an instruction to find a difference between an observed value and an expected value, square that difference so we're not dealing with any negatives, and divide it by that expected value to give us a proper ratio here. And then add up all those together. This will make more sense in a minute here. But this is the test statistic that we go through, or that we use when we go through the steps of hypothesis testing for goodness of fit, for testing the distribution of a variable. So when we do our hypothesis test, we always start with a step 0, which is assumptions check. Without this, we don't know if we can even use a test at all. If this is not met, then we can't even do the test, it's not valid. So what that means, with this specific test, the assumptions are we need a minimum of 5 values for each of the expected. And that's based on how many data points we have. If we only have one person in a category of a data point and the expected proportion, it won't work. And I think there are a couple others. Tim, feel free to jump in at any time.
No, I didn't want to interfere with your
interrupt me.
stream of thought. So remember, we're working with frequencies, right? And typically these are categorical data, or you probably call them nominal data. Hence the spring, summer, winter, and fall. They're categories, right? Since we're doing a complete census, there's no randomization of selection because it's everybody who ever played in a soccer game, a World Cup class soccer game. So that's all well and good, but the expected, these are frequencies, okay? So generally the rules that apply for frequency data, and this crosses over into parametric statistics as well. So some of the things we don't need to worry about, like random selection here, because we're taking everybody. This is essentially a census of soccer players. So at the end of the day, we need counts to make this work, or frequencies. So with that in mind, let's lay out, pardon me, I'm getting ahead of myself. I never do that. I just like to do the numbers. So step 0, we've got our assumptions. It's nominal data or categorical. We have frequencies. We have a very large sample. So the minimum of 5 count for expected, that's not going to be a problem. Now, one thing that's not stated in how this problem originally was presented was how do you calculate the expected counts?
Right.
Now here, 4 seasons, 100% divided by 4. Oh, I'll use purple. I like my purple chalk. It goes with my bandana. 25% per season. But what happens if, like in Hardy-Weinberg, you don't have that? Well, then it's going to be big N, total count of observed values, times some percentage sub I. So P, so we'll do I'm going to use the Hardy-Weinberg principle as an example. So if P is 0.6, then P squared is 0.36, okay? And since P plus Q have to equal 1, this must be 0.4, and Q squared would be 0.16. Well, this only gets us to 52%. It's 2 PQ makes up the rest, right? So you're going to have 2 times 0.6 times 0.4, which is 0.48, and 48, and this gives us our 100%. So in many questions, the percentage for each category will be different. Here in the example with Hardy-Weinberg, you can figure that out from simply doing the math on the quadratic equation.
Can I just jump in to explain this one a little bit more?
This one?
Yeah.
All right, so Hardy-Weinberg is p squared,
Plus 2PQ, right?
that's right,
So whenever you have two gametes,
right?
two possible alleles,
You're the bio guy.
yeah, two possible alleles for the gametes, right? Allele 1, P, allele 2, Q, right?
Yep.
So then when you multiply them together, that's what gives you this right over
And
here.
as from the math nerd's perspective, that's a perfect square trinomial.
There you go. That's all I wanted to jump in with that, right? So then you get this, this, and this, and these are your expected proportions. And then you
Mhm.
do an observation study to count out how many phenotypes you see that correspond to these genotypes. And then you
Go from there.
Yeah, exactly.
So if we were to set that up, we would have 3 categories. We'd have the p squared category, probably the 2pq category, this is how I usually do it,
Yeah.
and the q squared.
So yeah, you can do it like that. Another way
And then you'd have your observed,
yeah.
and then you'd have your expected.
Another way to present it is the PQ
Yep.
and then P.
Oh, look at you making
Q.
that
So
contingency
this is the
table.
yeah P
Yeah.
squared, Q squared, PQ, PQ because
Yeah.
it's commutative, so
Yeah.
it doesn't matter which one's first. And here's your two PQs,
Yep.
and there's your P squareds,
And this makes perfect
Yeah.
sense too when you're doing contingency table probability. I like doing it this way, but you know, at the end
Well,
of the day,
yeah.
you get the same answer either way.
you get to this. It's,
Yeah.
it's just when you do the multiplication,
Yeah.
it's good. Like first gamete, second gamete. But we will now.
Curses. You did geometry. It's a square.
It's yeah.
Huh?
Yeah,
Huh?
it's yeah.
Sorry, I'm easily amused.
That's good to be this excited about math. We'll actually flesh this out now and present this one next time because we clearly both really enjoy this.
Well, you know what we're going to do? Well, I'm just jumping in here. Let's do the soccer player thing so we don't forget about that.
Yeah.
And then what we'll do, while you're doing some chatting, I will throw some numbers up on the other chalkboard here, and then we will segue straight into Hardy-Weinberg as the second example.
Awesome.
Let's do that.
Sweet.
Okay, so give it a scrub, and while you're doing that, I'll think about Hardy-Weinberg.
And I'll just show my back to the audience. Hopefully
Oh,
there's
that's
nothing
okay.
on my back. Well,
That's okay. Smack!
what does Adrian say? Cut this out. We're live.
No, there's not going to be any editing today. So what you see is what you get. This is
That's right.
live as it's happening.
All right. So step 0, assumptions check. This answers the question, can we even do the hypothesis testing in the first place? Is the hypothesis test valid? Will its results be valid? And then steps 1 and 2 are the actual question itself. So step 1, H naught, which is the expected and the observed. So
There's no surprises.
no surprise, thank you.
That's right. The data are very close to what we expected to see.
The data, right, so we got the distribution we were expecting. Yeah.
Correct.
So expected distribution, I'll just write it like that then. Thank you, Tim, the word guy, distribution. And our HA is unexpected distribution. So the logical opposite of this guy. So different distribution. You can tell I did not prepare a script for this.
But that's what makes it good. This is entirely on the fly.
Oh yeah, off the cuff completely.
You can't even turn the radio on anymore and listen to on the fly announcers doing the chit chat because it's all scripted these days. It's no fun anymore when people go, "Oh, I totally screwed that up." I can remember back in the day occasionally dropping the occasional F-bomb. But
Yeah, back in your radio days, yeah.
Back in the day.
All right, so now, like I said, our steps 1 and 2 are the question itself, right? So we have, did we get the expected distribution or did we get a different distribution? And our step 2, or alpha, how much uncertainty are we willing to expect, or are we willing to accept? Which I think is how they describe it sometimes, Tim? If I'm
Yes, that's right.
Yeah, okay.
So remember as well, I always come back to this because I know it's going to be an exam question. Remember, this is 1 out of 20, right?
Yeah.
So alpha, the level of significance, also quantifies the chance of a type 1 error, a false positive. So we're willing to accept every 20 times we repeat this with the same population, same technique, same everything, we'll get a false positive approximately 1 time in 20, maybe 1 out of 22, maybe 1 out of 19. These are all approximates. Remember, in statistics, nothing is exact. If someone says the probability of this is exactly that,
Are you exactly sure about that?
because in stats, you never say yes.
That's correct.
You say maybe.
Good. So now, steps 1 and 2, the question itself. Steps 3 and 4, how do we go about answering the questions? We need 2 things. We need a test statistic and a critical value. And we're going to go through this test with the critical value instead of the p-value, which we'll present at a different time because it's a lot easier to do it with R or some other software. And actually, we will sit down and do a tutorial with R sometime in the near future. And then we'll use all p-value exclusively for that. Cool. So step 3 is the test statistic, which is this guy. Good. All right. Chi-squared, our test statistic, which we can denote something like this. Typically, I see a naught there, so the subscript 0 for a test statistic. Step 4 will be a critical value, which we cristical. Okay,
This is why I just call it crit.
I think I need to lay off numbers for a little while and start practicing some words and letters. This just all looks like a string of variables to me.
Actually, this looks like something tasty from Mary Brown's Chicken.
Oh, I had Mary Brown's yesterday.
Oh,
We're
yeah?
not sponsored by Mary Brown's, but should be.
But Mary Brown knows all about. I gotta do it. Mary Brown's breasts and thighs are delicious.
Oh my
They're
God.
chicken, and they're crunchy, and they're tasty, and I'm gonna move back over this way.
Get off the stage. Where's the cane from the side there? So this one could be something, I don't know, sometimes I see it with a star there, although it's kind of awkward when you have the, so. Just to differentiate, test statistic, critical value will be unedited.
That's right, and that's a table lookup.
Yeah. That one we actually did like 2 seconds before hitting go live. So step 5 is compare the two. Which basically we want to know if our test statistic falls within a rejection region, which means that do we scrap our H null? There is reason to believe that, yeah, which I'll draw in a second. There's reason to believe that the distribution is different from expected. Step 6, well, I guess decision could fall under either one. Explain. It's great if you get to here and you say, okay, we rejected the null hypothesis, and that's the conclusion we came to. Great. What does that mean? Actually, put this back into
Context
physical
is king.
That's right. Context is king. Good.
All right.
All right. So now that we've got this overview, let's take these numbers that we have here that existed in the ether somewhere that we've magically pulled.
I really have to bring a better chalk brush. I have to say, because this is live and I'm easily amused by trivial things. I don't think this chalk brush has been taken outside for a good banging ever. Like, there's probably 5 years of chalk dust in here. I
Five,
guarantee.
probably more. I mean, look at the
Probably
look at the
more.
difference in style. This is the
I know.
older style. I mean, I had this in elementary, and then this was like. Look at
Did
that.
you ever have one of those whipped at your head?
Probably.
Ah!
Not that I remember.
Well, that would explain getting whipped at your head.
There we go.
All right, so
Good. So let's calculate our test statistic here, right?
let's lay the data out,
So. Oh yeah, I guess that would be the.
because otherwise you're calculating something and our observers are going to go, what the hell are you doing?
I'm just gonna dial this back a little bit. So spring, summer. What comes after summer? Fall.
Fall.
Yeah, depression in Edmonton. That's what comes after summer.
right.
And winter. We go from plus 35 yesterday to minus 35 here.
Yeah.
Oh my
So
god.
just keep in mind, Edmonton is almost at 55 degrees north latitude, which isn't the land of the midnight sun, but it's pretty damn dark in January, and not a lot of daylight. So.
No,
Hence, seasonal affective disorder.
sad. So here we have our, this will be our observed value. This is the actual data in our observational study. And here's the expected, which is the proportion.
And we calculate.
Yeah, exactly. So here, because we have 4 and we're saying that it's random where people will be born, or sorry, into which season a person will be born, 25%. Long-winded way of saying 0.25 times
Big N.
big N, which is the number of observations that we made. Our big N in this case is 1,000, because we just cooked these up. Hence,
Okay.
in the ether somewhere. So 25% times 1,000, that gives a 250 here, a 250 there, a 250 here, and you probably guessed it, another 250.
Right.
So then, this is what we expect to get. What did we actually get when we did the study? We got a 200 here, and a 250 here. Oh, looking good so far. Then we got a 400 and some, there might be something fishy going on, and a 150. Okay. It seemed to start off all right, but then something weird went on here. So let's see if we actually.
And the thing to keep in mind, to have a statistically significant result, in other words, we end up rejecting the null hypothesis, only one category needs to be significantly different from all the others. That's all it takes. So we should be very suspicious of either this one or this one.
Mhm.
Difference here is 150, difference here is 100. So it may be that both of these are significantly different. These two, probably not. But we're going to find out shortly.
Just more on that though. If one of them's off, logical necessity, the other one, at least one of the others has to be off as well.
That's right.
Okay, anyway, so from here, we'll do this. It's easier if you set these up as a table, right? Because what this means, just to write that out mathematically, is you have O1 minus expected 1 over E1 squared plus O2 minus E2 squared over E3 plus ... however many you have, right? That's what it looks like. I don't know what you're talking about. That was always a 2. All right, so here we'll do O minus E, right? Negative 50, 0. What did you say, 150 before?
Yep.
And negative 100. And now, you know what? I'm just going to do it in this column because I can. Square it. So that means. Well, now I just made it
2,500.
awkward. Now I have to erase them. I may as well
That's
make
okay.
another
Not a
column.
big deal.
0 squared is?
Diddly.
150
We
squared
need a
is-
symbol for diddly.
We do need a symbol for diddly. What's 150 squared?
A left null. 2250.
Thank you. And then here is 10 thou.
That doesn't make sense.
I think there's one more zero here.
You put another 0 on that.
Yeah.
Yeah, because 15 squared is 225, and then another 2 zeros. Yeah, that's right,
Yeah, there you
22.5 now.
And
Yeah.
then this one is 10 thou. Right? Yes.
That's right.
And now this over E. Right?
That's
Did I get that
correct.
right?
Yeah.
This divided by 250
Expected. Yeah.
is
10.
10.
Yeah. Ah, we're already significant.
We'll get to that in a second. This divided by, doesn't
This.
matter, because it's 0. This divided by that is,
Calculator work or monkey work with Tim and John. You do the other one, and I'll do the 2250. Because if we expect students to do it by hand, we
should
can't
do-
choke out on this. Right?
Yeah, I swear it's just because there's a camera on me, I swear.
No, it's all good.
Okay.
So this is,
Yeah, there we go.
that's exactly 9. Yeah, because this is going to be 1,800 plus 450. Yeah, so this is 2250, 90.
And then the
Or 9, sorry. Ooh, baby, there we go.
sum is 49. 59.
No, it's got to be 90. He said, oh. Well, that adds up to a lot.
140. So that's our test statistic. Grossly significant.
Yeah.
So what this looks like when we compare this, that's not proper. Let me just do that. So the sum of them, this is our test statistic.
Mm-hmm.
Now when we compare this,
So the chi-square curve changes shape according to the sample size, the degrees of freedom, which we haven't talked about, by the way.
yes.
Degrees of
Chi.
freedom for chi-square, goodness of fit is the number of categories minus 1. So here we have 3 degrees of freedom. And the critical number from a table lookup or using software for 5% significance is, I've got it written on the other chalkboard behind me, is 7.815. So that marks this spot here. Go ahead and fill it in if you want. So, and this is 0, and infinity goes this way. So any test statistic that lies between 0 and the critical chi-square is a fail to reject. If you're equal to or greater than, in other words, further away, you're statistically significant. And this bad boy, way out here. And QED?
yeah, that's it. So that's our comparison now, because our x, sorry, Jesus, g squared is way out in the rejection region.
Yeah.
So we get, I've erased them. We rejected our h naught, stating that we got the expected distribution. We got something far off of the expected distribution. That is a huge test statistic. So good. And then when we explain it, we just say that no, there's clearly a bias of when
Yeah.
players are born. It's like people are fornicating here and birthing here.
That's such a harsh word. I prefer the use of the phrase knocking boots.
There you go. All right. Well, that is now on the internet. So as my gift to you, internet, take that and do with it what you will.
Knocking boots.
Yeah. All right. Good.
But the thing is, when we look at this, all with the exception of this one, these are all statistically significant. But remember, we have this huge sample size. And remember, a rule of thumb in statistics is the bigger the sample size, the more information you have to work with, and the more, I'm going to use the word accurate, the more reliable your result is. So with a sample size of 1,000, we have the differences will produce a much larger test statistic, simply because we have more information to work with. I mean, we can get all mathy and chase this around, but do you really want to do an epsilon delta proof today?
Sure. No.
No.
Let's jump to this.
You lie. My point is, small samples can justifiably, in most cases, justifiably be questioned. The results of small sample studies can be justifiably questioned because there's not enough information. But when you've got 1,000 count here, like we do in this example, which is strictly to make the math easier,
Oh, yes.
you're going to get these ridiculously large test statistics if there's a difference. So this is a contrived example. Don't put too much stock in this, and I will go look up that study and share it with everybody at another time. Okay, Hardy-Weinberg?
Yeah, if you wanted to jump to.
Well, I set it up for you, so.
Yeah, sure.
But while you're scrubbing the board, so just to recap, that Hardy-Weinberg is a geneticist's formula. It's a quadratic equation comparing, I think the original study was with bean alleles, was it not correct?
You're thinking of Mendel and
Mendelian.
Yeah, Mendelian genetic,
Right.
which is two laws of segregation and a independent assortment.
Yeah.
Which means that independent assortment means that different genes will separate the different gametes
Mhm.
independent of one another. Right, they don't follow what another one does,
Yeah.
and then segregation means that the two different alleles separate to
Okay.
form different gametes.
So that's what we're screwing around with.
So in short, we have some gene P and some gene Q.
Okay, and we should write down the Hardy-Weinberg formula as well. So just, not everybody out there is doing biology, although they should.
I was about to say, took the words right out of my mouth.
Equals 1.
Yeah.
That's the goal. Where P is 0.6 and Q is 0.4.
Yeah. So we have two different alleles, so two different versions of a gene, right?
Yep.
This could be something like brown hair versus blonde hair, although the numbers would be like 80% and like
Yeah.
10%, whatever.
Eye color as well.
Eye color, yeah. So these types of phenotypes for human traits
Mhm.
usually take a lot more than just two genes. And
Oh, yeah.
there's a lot of interaction and whatnot.
One of, back when I first started TAing in the 90s, I worked with a gal who was probably one of the smartest people I ever met. She's a physician now and specializes in addictions.
Oh,
But
yeah.
her first degree was in molecular biology. Her second degree was a master's in genetics. And then she went and became a general physician and then specialized. To make a long story short, look at the big brain on you. But she comes from a family of academics.
Mm.
So it goes back to nurture versus nature.
Yeah.
If both parents are academics, is the child going to be gifted? Or does the regression towards the mean no?
Yeah.
Okay, we're getting out of hand here, but the point is,
See, that
nature
one's-
versus nurture comes up in many, many contexts.
That's why with dealing with genes and alleles like this, it's a lot easier when it's just a physical phenotype that you can see. There's so many other factors to take into account when it comes to personality traits or character traits like that, right?
Yeah.
Because you might have, overbearing parents that push a kid.
Tiger mommy.
There you go. Push a kid away from academics, a kid that would have excelled as an academic, but they were pushed away. Or you might have a kid who has a propensity for academia in a family that really rejects that sort of thing, right? Like, what are you doing? Go work in the fields or whatever. And
Well, I
It's
grew
hard-
up in a
in short,
backwater
hard to
part
tell.
of Canada, and one of the annoying things as a child was I was always curious about everything, but various parental units and relatives of parental units. We still say parental units anymore.
you know what? That I remember that one from my childhood.
Yeah, well, it's don't get above your raising. And I'm going, really?
But then how do you progress as a society?
You can't. You can't.
Exactly.
But, in backwaters, whether it's in Canada, Europe, and pick a part of the globe, there are communities where people think ahead, and then there are people in other communities that fear the future. And, that's a rant for another time. Let's leave that there. Because, I'm going to start naming names here. I don't want to do that.
So let's say we're dealing with turtles and turtle shells because we're a big fan of Mario. Green shells, red shells. There we go. These are the phenotypes, right? So we measure P to be a certain value, right? We suspect our green shells. So P is green shells. God, I really gotta touch up my
Works for me.
red shells.
What about the blue shell? That's just for Mario
Nope,
Kart.
no blue shells.
Okay.
No blue shells allowed. All right, so green shells and red shells, right? And we suspect that the proportions, if we were just to go out and count all the turtles with green shells, red shells, it's 60-40.
Right.
That's what we expect. So if
Yeah,
we were
that's
doing
right.
a count of 1,000, we expect to count 600 greens and 400 reds.
Right.
Exactly. So
Give
now,
or take, right?
that's right. So
Plus
now,
or minus a few.
and those are the only two possibilities we're allowing because we don't allow blue shells or yellow shells, or if you're thinking of Super Mario World, right?
Yeah.
We have, whenever Yoshi would eat a yellow shell, he would pound the ground.
I'm
right?
sorry, but that just reminds me of don't eat yellow snow.
Also very good advice.
Sorry.
Green shells are just a projectile. Red shells, you spit out fire, and blue shells, you fly. But we're not allowing wings or ground pounding.
All those things seem to have a relation back to mushrooms.
Poor Mario.
Yeah.
His addictions. Okay, so these are the only two possibilities, meaning that a turtle has to have one of them.
Mhm.
Otherwise, you don't have a full genome of a
Yeah.
turtle, right? So P plus Q has to equal 1. Right.
And they're mutually exclusive because you can't have a calico.
Exactly. You can't have a calico
Yeah.
turtle shell, yeah. So now we have P plus Q, but now what happens when a turtle
Meets another turtle.
meets another turtle
You
and
have-
becomes
You
enamored?
know, back in the 70s, there was a song called Muskrat Love by the Captain and Tennille. But this could be Turtle Love.
There you go.
Okay,
so
I'm
turtle
sorry, I'm
A
sorry.
meets turtle B, and
Yeah.
they make little turtle babies. So now these gametes, we don't know which allele turtle A had, right? But a 60% chance of a green shell, 40% chance of a red shell. And then turtle B, same thing, right? So their babies will have, when you FOIL this out, right? First, outside, inside, last. You get P squared plus 2 PQs plus Q squared. Right? So if they have 100 little turtle babies and they all make it to the sea, which is highly unrealistic, man, nature is cruel. Those seagulls got to eat.
Well, you know,
One of those things.
crunchy hors d'oeuvres. Sorry, I like turtles, so. I'm not going to go to the candy joke.
I was about to
Turtles,
say,
turtles, wow, wow, wow.
rah.
Yeah, shut up, Tim.
I love turtles. Okay, so when we actually do that, the proportions now, we fill in the numbers, we get a 0.36, a 0.48, and a 0.16,
Mhm.
which adds up to 1.
That's right.
So this is what we expect from a clutch of turtle eggs. And yes, I think that is the term.
That's the correct term.
I know it's the term for birds.
I think it's actually a term for just about anything.
Anything with eggs, eh?
Yeah.
Okay. So a clutch of turtle eggs will have.
But knowing biology people, I'm sure someone coined another word phrase just to get their name in a book somewhere.
There you go.
Because it's all about the fame, yo.
That's right. That's right. Okay, so now using numbers that Tim has so generously cooked up for me, we have a P, a Q. Is this showing up well on there?
Yeah, keep going.
Well enough?
Yeah, no, we got everything.
Okay. Ooh, careful with that shot there. So what did you say? 40, I think?
Now that's the observed.
Yeah. So these are observed. So,
So these, so it's going to be 40,
yeah,
and then Q is 15,
yeah,
and then 15 for bottom left,
yeah.
and then 30 for bottom right.
Okay. Good.
So those are observed values.
So we actually counted the
That's
little
right.
babies that
Yeah.
came out of the ditch from the clutch of
That's
egg and are
That's
flopping
right.
their way
and
to
they
the
add up
sea.
to 100. Keeps the math easy
Yes.
for now.
So turtle A and turtle B had 100 eggs in their clutch.
Turtlings.
Turtlings, thank you.
But is that a noun or a verb? We're verbing the noun. Shut up, Tim.
I
Carry
think.
on.
Oh yeah, no. Just because it's the gerund, it doesn't
Yeah.
mean that Did I pronounce that right? Durin? The ing ending to noun the verb?
I have no idea.
Okay.
That's,
Or is that
we'll leave
verb in
that
the
for
noun?
posterity to ponder.
English teachers out there, chime in. All right.
Science, you can make it up.
There you go. So 100 little turtlings from the clutch of eggs. Good. So now we need to calculate. We'll do the same sort of table and all that because that actually worked out.
Now we
Fairly
need
well,
the
right?
expected count.
Okay,
So the expected, where'd my chalk go?
yeah. So I'm just okay. Are these? There's different types of dominance for alleles. If this is strictly dominant,
Mhm.
then if they have a P and Q, then this would just appear as a green shell and green shell, right? Or if it's a blended dominance, incomplete dominance, that would be like orange shell, for example, right? Whereas this homozygous would be strictly green.
Oh, look at you making up words.
These are actual biology terms. Man, okay. Probably should have scripted this. Oh well. Enjoy, internet. Enjoy. Okay. Who's doing it? Right.
I want to make a table. I want to make a table.
You make the table. Yeah.
Okay. I'm just sort of
Otherwise,
standing-
I'm just gonna
I feel like
ramble.
I feel like I'm a third wheel. So this is the expected or expected counts based on our percentages. I'll get out of the way here in just a moment.
No, this is good. This is
Okay.
good.
So these are observed.
Or no, these,
Sorry, these are expected. My
Yeah,
bad.
these were the observed.
It's the sound of math.
Yes, the yoink.
Okay, can you see this? So all I just did some quick calculus. So 36%, 48%, 16%, those were the expected percentages. So of course, because we have a nice easy number of 100 count, we have 36. The 48 is actually 24 and 24. That's why you see it like so. And then we have 16 here. So clearly the expected table here is substantially, well, visually appears different than the observed counts. Whether that's a significant difference or not, is we're about to find out.
Yeah, so we'll set it up the same way. So O minus E will go 40 minus 36. Right?
Yep.
And then here we have 20, or sorry, O minus E. So 15
right.
minus 24.
9.
Thank you. 9.
And we're ignoring the negative because we're going to square these away. That's the beautiful thing about chi-squares. No negatives. If you get a negative, you've gone wrong.
Or it's just the idiot at the board forgot to add the negative. Me.
That was the big one.
14. All
So
right.
the thing that's really different
Is
are
guys.
these two
Yeah.
cells.
So now O minus E squared. 4 squared,
You don't need me to help you with that.
negative 9 squared, negative 9 squared,
He's ignoring me.
14 squared.
196.
Very good. And now this is O minus E squared over E. 16 over,
36.
the hell is 16 over 36?
Well, that's 8 over 18, which is 4 over 9, which is 0.44.
4 over 9. And then we have 81 over
24, which will be 3, which gets you to 72. 3 and 9 24ths, which is 3/8, so 3.375.
3/8.
3 and 3/8.
Oh, 3 and 3/8. Yeah,
So
double.
3 point.
Oh. Adrian makes it look so easy in front of a camera.
Thank you.
196 over,
16?
yeah, is,
Well, 6.
both
So
divisible by 4.
196 by 16. It's going to be 16 times 10 is so it'll be 12 and some change. So 12 is going to be 160. Another 32 is 190. Oh, there we go. So essentially 12 and a little bit.
12
And
point
that
whatever.
little bit is 0.25.
Good. Oh boy. All right. So, in short, This
Oh,
right
there's
here
nothing
gives-
short about this. This is 3 point, I have to do this.
Go ahead. Yeah, you take over. Brains fried.
Okay, I'm trying to write sideways and that's failing miserably. And 4 nines is
0.44.
So we'll do another 4 there, so this is 1250. So what do we got here? We've got 12, 18, this will be essentially 19 and a half. So summing this is approximately 19.5. Unless you want to get fancier, but I'm not going to worry about it because this is substantially bigger than any critical number we could possibly have here. And the critical numbers here will be calculated on 2 degrees of freedom. It's the number of categories minus 1, and we only had 1, 2, 3 categories.
Yeah, this counts as
Yeah.
one. Even though, so this would have worked itself out.
Yeah,
Right, 2 of those. So.
right.
Yeah.
Anyway, the bottom line is, this is way larger than the critical number, whether it's on 2 degrees of freedom or 3 degrees of freedom. This is essentially 2 times the size of the critical number. So our p-value is probably 0.001 or smaller.
So highly significant. Reject the 0.6 and the point.
That's right. So
Four.
what we're really saying here then is these are mutant turtles. I'll bet they're somewhere between 12 and 20 years old too.
They probably crawl around the sewers, eating pizza,
Hang around with some old rat dude.
rats, swinging martial
If I
arts
had my
weapons.
beard, you know, I could be Shredder. No, what?
Splinter.
No,
Master Splinter.
Master Splinter.
Yeah.
No, Shredder was the bad guy.
Shredder was a bad guy.
Well, I could be bad guy. But the point is, these are mutant turtles, which means at least one of these shells is calico.
Well, there you go.
That's chi-square goodness to fit.
Yeah, and then next time we'll do independence and homogeneity,
Yep.
and maybe we might even script it out next time.
Yeah, well, no, you know what? This is very ad lib. Nothing here was planned. The extent of planning this out was me to write a few numbers down on this
Yeah.
other chalkboard.
And me fumbling the arithmetic on the
But
board.
that's not. But this is how you know it's real. In the age of AI and the age of people who edit the hell out of their videos,
Yeah.
I personally
We dare to be different.
exactly, because this is what you would see if you were sitting in class. I work with students that are generally trying to turn F's into D's or C's or B's. And I use humor a lot, and I want to make sure that everybody understands that mathematics is an error-prone endeavor. Screwing up is how you tell people that it's okay to screw up.
That's right.
Because a lot of times I'm ranting. A lot of times in high
Rant
school,
away.
it's like, you got to get right every time or you're a bad person. Well, I don't buy into that.
No.
We try to have fun, and if you like this ad lib environment, send us a note.
There you go.
Because
And-
I propose to keep doing it this way. I don't want to spend time editing, making this look slick. You can find this anywhere on the internet where it's edited and made to look slick. I don't want to do that. I want to have something that's
Real?
exactly.
So we
And
got
I know damn well. Sorry, I know. Go ahead. What?
You know damn well. No, finish this thought. real
Okay,
quick.
I know darn well
Yeah.
that Adrian, although I'll never get a word in sideways with Adrian, because once you get, Adrian's part 3 of this triumvirate of idiots that do math on the internet. It's a good Roman word, you know.
There you go. Yeah.
Once you get him going on a topic that's close to his heart, you might as well just sort of sit back, put your feet up, and chill. I
Oh, yeah.
recommend mushrooms. Sauteed with a nice steak, sauteed with a
Not
nice
as-
steak, and just enjoy it.
Okay, there you go.
Because the man just goes with what the hell's your name again? Lorenzo. See, I'm getting old and a little forgetful. We do a good banter back and forth, and I kind of like that because one of the things I do with my students too, I don't force anybody to do this, but if someone's willing to stand at the board, I'm willing to do what we do here, exactly what we're doing. I'll show them how to do something, and then I'll coach them through it, because teaching math is coaching math. You want to make someone a success in academia, especially that transition year out of high school. You're not teaching, you're coaching. Am I ranting?
Dave, rant away. You got the microphone
I
right
know.
now.
So it's my laptop.
So we have Mean Machine Rex here commenting on the new Blackboard. We're actually at the university right now, just sort of an impromptu, hey, let's just use this space. And
Yep. So if
it's
you want to
free.
see, this is one of the largest campuses in Canada, by the way. If you look up University of Alberta on Google Maps, you'll see this place is a sprawl.
Oh, yes.
Oh yeah. Oftentimes at the start of each semester, you get new students asking, can I get from this building to that building in 10 minutes? And that's a legitimate question.
Oh, hell. Yeah, you'll have something way up here in engineering, and
Yeah.
then guess where your next class is? Way the hell down here in TELUS.
Just
Who
remember
scheduled that?
The Pythagorean theorem is your friend. You want to go in a straight line.
But that's the problem. Like, there is no straight line. There's no straight path. So,
But that's a mathematical optimization problem. How
Yeah,
can
there
you
you
get
go.
from the northeast to the southwest or vice versa
yeah.
with the minimal amount of jigs and jags and jogs?
Now in summer it's good, but during the school year when there's a sheet of ice on the ground, and in Edmonton here we get this persistent wind at minus 30 that just strips away all will to live or to exist at all.
I have pictures from not last winter, the winter before. I dropped my car off to get some work done. It was only about a 2 kilometer walk to my house. And I walked home, but the wind was whipping and it was minus 30 something. So I've got I've got a good collection of heavy weather gear because I'm old and I've done other things. And I had a big beard at the time. And I took a picture when I got home and I had an icicle hanging off my nose. My beard was the typical Antarctic explorer beard full of ice and whatever. But when I got home, my nose was burning and I took a picture, selfies, got to do that, right? So there's this icicle, this friggin' long hanging off my schnoz. Did I just do an accent? Hanging off my schnoz, eh? Hey, what, eh?
Hey, they don't need to deal
Oh,
with
sorry.
what we deal with. Those
So
Aussies.
I suppose that's a 55 degrees north latitude problem. I suppose for people who live closer to the equator, the whole thing can be turned around into, it's high noon, why are you outside? Go have a nap, then go out when the sun's down later, that kind of thing.
I prefer that than the minus 40 that we get
Oh,
here.
we got another comment here.
Yeah, no, they're just commenting on the
Okay.
U of A being at the U of A. So.
Okay, yeah, cool.
Yeah.
So, the U of A is, like I said, a huge campus. It's a research university, huge engineering department here,
Yeah.
huge medical department here. The math department's got a lot of very keen people and a lot of very accomplished people, but they hide their talents. You have to actually go searching for their accomplishments. But if you look at the math department people and then you cross-reference their names with publications, it's you go, wow, okay, could actually learn something here.
There you go. Yeah.
Yeah.
All right.
All right, so this was an experiment. I would welcome feedback on it. You can either do it on the chat right now if you want, or remember we have an email address. I'll pop the email address up here. And this is going to end up on YouTube as well.
Will it now?
Oh yeah.
Do we want to immortalize some of this?
Actually, I do want to immortalize this. I want to.
All my many arithmetic mistakes.
Yeah. Well, welcome to hell. Remember what I
uh,
said. Arithmetic mistakes makes this real. So what's our email address?
That's a good question. I think is this.
Yeah. The Tutor Wizard. Did we have the 2 at the end or not?
We do. Did we have the though? I think we did, didn't
Yep. So the
Gmail.
Tutor Wizard 2 at
we? Gmail.com.
So feedback is highly welcome. When this pops up on YouTube, if you want to drop a comment there, I would appreciate it because it's my intent to do more of this. We're statistics. We have calculus coming up. I want to do some calculus stuff, especially for the first 2 semesters of calculus, where we want to target this to the student who's not too sure they're going to pass the course. So we don't want to talk over your head. You want to get somebody talking over your head, go to class, because sometimes the profs they're talking to that upper quartile or the upper half. That's not how we're going to do it. Adrian does more advanced math, so if you're a math major, tune in for Adrian, because yeah. Yeah.
Oh, without question. Yeah.
I don't want to steal his thunder, so I'm just going to let Adrian sell himself. That didn't come out right. He'll do his thing. Whatever that thing it is he does will be. I had a stroke one time, so I
That was
recognize that.
almost a coherent sentence.
We're going to slip back into stroke talk. But I also tutor students in Faculty of Education. They have to take some math courses, and this is fundamental. They touch on what is group theory, number theory, little things like that.
Yeah, so algebraic structures in
yeah.
general, not just group theory.
Well, one I always like is, so here's, I'm not going to shut up yet, so you're going to have to just sit there and listen. They teach them how to count. Because remember, if you're teaching first division and second division, you're teaching kids how to count. But how many people actually remember the mechanics of learning to count? Ask an adult sometime, well, here's a bunch of numbers, how do you count? Oh, well, they're going to probably do the 1, 2, 3, 4, 5, 6, 7, 8, 9, ladybugs at the Sesame Street, look at it. But the mechanics of it, what's the business of filling the ones column, carrying to the tens, fill that, carry to the, they forget how to do that. Everybody's internalized it. But if you make them do it in base 7 or base 3, now you got to think about it, and now it's hard. And not only do you have to count in base 3, you get to subtract, you get to multiply, you get to divide, all in base 3, or base 5, or base 7. Not in base 8, or base 16, or base 2, because any monkey man can go and find an online calculator for that. But to do it by hand, it's really interesting, and it makes you think about things in a totally different way.
Can I just comment
Yes, you
on
can.
that?
I
Because
can see that.
this is how I think about it, right? So when we're doing base 10, right, we have 10 options for what these digits can be, 0 to 9, right?
Yep.
Now if we're doing a different base, say base 3 for some weird reason, right?
Mhm.
We have 3 options, a 0, a 1, or a 2.
Because remember, we start counting at 0.
That's right.
So if it's in base 3, it's the base minus 1 is the maximum digit.
So this is kind of how I visualize it. I take each of these, what were originally lines for the positions, right? And
This is how I learned this in 1969.
There you go. So I visualize it as a container. How
That's
much
right.
stuff can you put in each of these positions, right? You have
We had to
nothing.
do this. Mrs. Mooney, Clarice Mooney was my grade 1 teacher in 19. She got a bucket of wooden thread spools.
Nice.
I know, old tech. People used to sew things themselves, you know. And she would say, go and make 15. Well, you'd have to fill this bucket and then carry over.
There you go. So that's the carryover, right? So you can have nothing in it, right? Or one thing or 2 things, right?
Yeah.
And then if you have stuff to carry over, right? You have another group. And then right here. So this now, how many somethings do we have? 1, 2, 3, 4, 5 somethings,
Yeah.
right? But now in base 3,
How would you put this? So you're only allowed to illustrate the number using 0, 1, and 2.
yeah.
So here we have a base 3 value that would be 1, 2, 2 in base 3.
Yeah. That's just how I visualize it. But
Well, this is how I teach it.
I learned this from Adrian actually about.
Well, see,
different
Adrian's
bases.
old. Well, I don't know. He's not that old. I'm ancient. Adrian's sort of in between. Were we getting somebody telling us to be quiet here?
No, quite the opposite. Dyscalculia?
Dyscalculia. So you've heard of people with dyslexia, right? Dyscalculia is a thing. Dyscalculia means people have a hard time dealing with arithmetic.
Ah.
It's just a wiring issue. Some people are born that way. TBI, traumatic brain injury, can invoke this. So dyscalculia is the thing. I don't have my glasses on. What's the rest of the comment?
Difficulty internalizing arithmetic methods.
Right.
Yeah.
So for a person with dyscalculia, graphical methods may be the way forward. Maybe. You know, what's interesting is last semester and for the coming semesters, I've started working with blind students. You try teaching mathematics where you have no visual aids. That forces you to think about mathematics in a totally different way, but it works. My math student last semester got an A and an A plus in statistics and in calculus. And I'm going to try and do the same thing with a new character coming in this fall. And at the same time helping my original student along the way. Because if you look at, so here's another rant. If you look at the modern math textbook, I'm thinking of Stewart Calculus in particular, but he's not the only offender. He can't be an offender, he's passed on now. But anyway, the point is, you don't need to have a 1,000-page book full of pictures. If you look at any of the older textbooks, I mean pre-World War II, maybe even pre-1950, they're very concise, and the words are chosen to describe the concepts. They're chosen carefully. And I think we need to get back to that, because it's too easy to fall back on that old chestnut. I know I'm old. It's a phrase.
Yeah.
A picture is worth 1,000 words. That's right. It is worth 1,000 words, but you can overuse it. And everybody who looks at the picture is going to have a different collection of 1,000 words. And now you've got confusion all the time.
So I think confusion's a good spot to cut it
Are you
off.
telling me to shut up?
Well, no, we're just already at 11:30, so we've got.
So
to wrap it up.
I take it to heart your dyscalculia comment. Who made the comment?
That's Mean Machine Rex. That we
Ah,
did a review
cool.
of
Yeah.
ours,
So sorry, I don't have my glasses on, and we're just using Lorenzo's phone. So thanks for your comment. I appreciate that. And dyscalculia is a thing, but there's a way around that. You just have the person who's coaching you with math has to think outside the box.
There you go.
If you, any good math instructor, I'm not shutting up, any good math instructor should have more than one trick,
Oh yes.
more than one way to explain an idea. And the goal, as any coach will tell you, is to find the way to bring your athlete or your mathlete along that works for that person. You can't put everybody out on a track and say, everybody runs 100 meters in 12 seconds. I don't think I could do that. When I was young, well, Ben, if you piss me off, maybe I could chase you. If I don't catch you in 100 meters, you're good. Because right now, I think if I had to run 100 meters as fast as I could and catch you at the end, I'd probably just simply fall on you and die in a puddle of sweat. Because I'm old. But the point is, with any communication, if the listener isn't getting it, the onus is on the speaker to adjust.
Absolutely.
Now maybe I'll be
Absolutely.
quiet now. Help me out here by pushing the button. That's okay, I'll do
All
it.
right. Thanks,
All right.
everyone. Hopefully, this was some coherent thoughts being shared. So yeah.